Hey everybody, today we've got 7-7 for you, the mechanical events of the cardiac cycle, which is basically just what's physically going on in your heart when it beats. So this is a little picture kind of representing the blood flow as it goes through your heart and the different parts of the beat. Alright, let's start out with some terminology. We mentioned this in the previous one, these words, systole and diastole. And systole is what we call the contraction of the heart, which we can see right over here, where the ventricles contract and squeeze the blood out the pulmonary arteries and the aorta. And then we have diastole, which is when the heart relaxes, which sucks in water from the vena cava and kind of goes into the ventricles. And then same thing comes in from the lungs and goes into the ventricles. Going back and forth between systole and diastole is referred to as a cardiac cycle. Cardiac cycle is all the events associated with the blood flow through the heart during one complete heartbeat. So we're going to begin when the heart is kind of in between beats. So after the PQRST. So between the T and the P part of the cycle, when the heart is completely relaxed. First thing that happens is ventricular filling. This is mid to late diastole, and so diastole is relaxation. So this is when the pressure is pretty low. So inside of here there's low pressure, inside of here the pressure is low. The blood is filling in the atria, we can see coming in here, and then also coming from the lungs here. The AV valves are open, which allows the blood to just naturally flow directly into the ventricles. So the atria don't really pump blood into the ventricles, they just kind of open up and let the blood kind of flow right in there. The ventricles are slowly filling up due to this decreased pressure, so that there's higher pressure out here, so causing it to be pushed inside. And that'll fill up about 70% of the volume inside of the ventricles. At this point, the semilunar valves are still closed. We can see here and here. And then we get the P wave. During the P wave, remember we have the SA node right over here. During the P wave, the atria contracts and takes whatever blood is left and shoves it in there. So that's about 30%. So 70% passively flows into there, 30% gets pushed into there. So that's when the atria physically contract. So most of the time it's just they're running through there, but then it contracts to force the rest of it into there. And then you get what is called the end diastolic volume, and I forgot to highlight that one, so I'm going to do that like that. Also known as EDV. The end diastolic volume is as full as the ventricles can get. So they are packed full. They can't hold anymore. So that's end diastolic volume. At this point, the atria, they kind of chill and relax. And what that happens is that causes the blood to flow back this way. But that's okay, because that causes the valves to close. So there should be no backwards flow of blood. As the atria, since they have now contracted, they need to relax. When they relax, the ventricles depolarize, and that causes a QRS complex on the ECG. Okay, the next step is going to be ventricular systole. Remember, systole means to contract. So what happens here is that blood flow going backwards closes this valve. This valve is already closed as well. So that gives us high pressure here in the ventricles. The AV valves close, which are this one and this one. And the SL valves, the semilunar valves, are still closed. So that closed off container is what causes the pressure to increase. When both sets of valves are closed, you have what is called isovolumetric contraction phase, big fancy word, for the ventricles are starting to tighten up, but we have a closed container. So what happens if you take a water balloon and squeeze it between your hands? Either it pops, well, that's pretty much it. If you're strong enough, it pops. And so what's happening is the ventricles are squeezing on the water balloon that is your ventricles, and then eventually it's going to pop. Well, the heart's not going to pop. It's going to go through the weakest area. Well, the weakest area are these valves that point in this direction. So right here, they point this way. These guys point down. so it doesn't make sense that the blood's going to go back through. So once the pressure gets high enough, eventually these valves pop open and the blood goes through. That is what we call the ventricular ejection phase, and it makes sense. The ventricles are ejecting the blood out. So the ventricles push the blood out at about a pressure of 120 millimeters of mercury. So when they take your blood pressure and you're 120/80, that 120 that's the pressure that your heart is forcing the blood out your aorta and your pulmonary trunk. Okay, the next phase is isovolumetric relaxation. I can't talk. And so what happens here, this is early diastole, so early resting. This follows right after the T wave. The ventricles have just pushed all their blood through, and then what's going to happen is gravity is going to cause some of the blood to fall back this way, and that's what closes the semilunar valves, is that backwards flow of blood, because we don't want it going in there, so the valves are going to close. Now, when the ventricles relax after pushing all the blood out, there's still a little bit of blood left in the ventricles, and that is called the end systolic volume. That is the blood left in the chambers after a contraction. So when it squeezes, 100% doesn't go squirting out. There's still some left inside, but that's okay, because it'll get pushed out the next one. So that's the ESV, end systolic volume. The blood, like I said, in the pulmonary trunk and the aorta are going to fall backwards due to gravity, and that's going to cause the semilunar valves to snap shut. And that increases the pressure right here in the pulmonary trunk and then also in the aorta. That quick little, it's flowing like this, but that quick little snap back and then hitting the wall, causing it to stop, causes a brief little increase in pressure in the aorta. And so what happens if we're monitoring pressure, the pressure kind of goes down, but then goes thunk, and then goes down some more. So this little dip right there is called the dicrotic notch. Dicrotic means to fork, like a fork in a road. So this is a brief little rise in aortic pressure as the blood flows backwards and snaps the valve shut. And then from there kind of goes back around and keeps on going that way. So here is a little graph that kind of looks like what you'll see in your homework. So the red is the aortic pressure, and so when the semilunar valves open and let the blood go through, the pressure comes out at about, or actually comes out and then reaches the top here at 120 millimeters of mercury. And then the pressure starts to go down until the semilunar valves close, snap, that's what that little thing is, and then it starts to go back down from there. The ventricular pressure, we can see that it increases once the AV valves close. That causes a huge increase in ventricular pressure as it's pushing all that blood out. And then we can see it goes down once all the blood is out, and then the AV valves open again and the blood passively falls in. In the atria, the pressure doesn't really get too high, because remember, they're thin, so they're not meant to have huge pressure. But what we can see is that there's a little bump in pressure when the AV valves close, so there's like a recoil in the atria, and then when they open again, then that lowers the pressure as the blood is filling. So all this right here is where the blood is filling, all these flat parts right there. And then this just shows what's what according to sounds. So what's not on here is the PQRST portion, or the ECG. So the lub we're hearing is the AV valves closing while the semilunar valves open, and the dub is due to the semilunar valves closing and the AV valves opening. So those sounds that you hear have to do with basically this one and this one, those guys closing. Those are your heartbeats. I don't know what this little guy there is for. Straggler. Alright, so during ventricular systole, contraction, the atria are in diastole, relaxation. Once they're relaxing, they can fill up with blood again. And remember, the AV valves are open, and so it starts to fill up the ventricles again, and you start the cycle all over again. Typically, from one beat to the next is about 0.8 seconds, which leads to our 75 beats per minute. Atrial systole, it only contracts for about 0.1 second. Ventricle systole is 0.3 seconds. So those two add up to 0.4. But the whole thing takes 0.8. So what's going on during the other 0.4 is called the, and I don't know how to say this right, I should look that up first, the quiescent? I'll have to look that up. The period that's in between beats is total heart relaxation. And that's just your heart just not beating, not contracting, no electrical activity between the SA node and the end of the Purkinje fiber. So it's just relaxation, which also allows your heart to refill. Blood flow, therefore, is completely controlled by pressure changes. If it wasn't for changes of the pressure in the ventricles and the valves, all that stuff, then your blood wouldn't know what direction to go. Blood will flow down a concentration gradient, basically meaning from high pressure to low pressure through any opening, whether that's a gunshot through a hole in your ventricle, blood will go through there, whatever decreases the pressure, easy. The right side and the left side of the heart will contract the same ways. The only difference is pressure. On the left hand side it's higher due to the fact that it's got to send all that blood throughout the body as opposed to just to the lungs. Alright, so that's it for today. And we'll see you guys tomorrow. Hope you have a good evening. Bye-bye.